Hi guys, is my voice audible to you?
Yes, ma'am.
Yes, ma'am.
Okay, fine.
Yes, ma'am.
Okay, just a moment, guys. Let me just open the file and we'll just start off with the session for today. Fine.
Okay, ma'am.
Guys, in the last session, how much we have actually completed? Can you recall? Guys,
Ma'am,
anyone?
we were talking about sigmoid function.
Sigmoid activation function,
Yeah,
right?
linear and sigmoid we did.
Okay, great. So we'll just go after that from that actually. Right? So my screen is visible to you?
No, ma'am. No, ma'am.
Not visible? Okay, okay, just a moment. Now also not visible?
Yes, ma'am. Not visible.
No, ma'am.
Okay, not visible. Just a moment. Now also you can't see, guys.
No, ma'am.
Now
Yes, ma'am.
you can see, right?
Yes, ma'am. It is.
Yes, ma'am. It is visible.
Okay, fine. Great, great.
Uh,
So we have gone ahead with linear and the sigmoid one, right? The up to this much we already did, right? Guys, up to
Yes, yes.
sigmoid curve we have already did, right?
Yes,
Okay.
ma'am.
So
Yes, ma'am.
okay, we'll just go ahead with tanh function, activation function then. So we can think of after sigmoid, tanh is another function like activation function that is very popular actually. Okay. So what it does in case of in case of tanh, it takes any input, whatever be the input we are taking into consideration, it takes any of the input and convert it into any value between 0 minus 1 to 1. Okay, so what it does, so this is the curve actually. So what it actually does, it takes any input. So it takes any input and what it does, it converts it into a value, into a value that is between minus 1 to 1 actually. Okay, so minus 1 to maybe write it as plus 1, that would be better to see at. So it takes any of the input, whatever be it, and just converts it in between minus 1 to 1. So the formula that we are actually using to take it out, that is actually e to the power, just a moment, e to the power z minus e to the power minus z. What is minus z, guys? Guys, what is minus z? It is the summation function. Can't you recall? Just go up, going up. So summation, the weighted sum that actually we did, we represented it using z. So here z is Z is that only. Okay, let us just go down. Yes. So Z is the weighted sum. So whatever be the input that we will be taking into account, that we are just putting it like on the power of E actually. So we want to take into account into in this format. So e to the power. Am I audible, guys? Can you hear me?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, fine.
Yes,
So
ma'am.
the formula wise, it is e to the power z minus z is the weighted sum of the input that we are taking into account minus e to the power minus z. Actually, it would be minus z. Now, what we'll be doing? We'll be just doing the same, but in the just a minute. Yes, but here we'll be just doing addition. Okay. So this is how it is. So z is what it is. Let me just write it for you. Z is the weighted sum, and what is E? E is a constant that is approximately around 2.718. Okay, so this is actually the values how we are taking into account. So how it actually works. So maybe let us give us the example as input value we are having. So whatever is the input value that is 0.6 suppose, and we have another value that is 0.4. These are my input for 10H for the neural network, and 10H be the activation function, and the weight that we are taking it as 0.5 comma 0.3. So these are my weights. So the input in the sum of the activation sorry, the sum of the weighted weight like the weighted sum actually. So how it would be? It would be like 0.6 into 0.5 plus 0.4 into 0.3. Okay, and we will be having the bias. Okay, so how it is? It will be 0.6 into 0.5, that is 0.3, plus 0.4 into 0.3, that is 0.12. Okay, and the bias, let us just keep the bias as 0.1. Okay, so we got the value as 0.52. Clear, guys? Up to this, is it clear?
Yes, I agree.
Okay, great. Now, after we are done with the activation, like, sorry, the weighted sum we did, now we need to put this value to the activation function. Activation function. So what we are taking in case of activation function, that is tan h we are taking, right? So in tan h, we will be putting this z value, right? So how will be getting it? E to the power 0.25 minus e to the power minus 0.25. After covering it all, we might get the resulted as like that would be around suppose 0.48. Fine. So this would be the value that we will be doing after the operations that has came up. So the neurons will give after it has all been done, after weighted sum, after putting the tan h function, after putting this value in this positions, we will get the output as 0.48. Okay, so this is how actually we get it through. So see 0.48 actually comes in between 1 minus 1 and 1, right? So it is acceptable. So my values are like this, like my input values are like this. I adjusted the weight along with my bias to get the value to get the uh, weighted sum like this. Now I have given the weighted sum in the activation function, and I got the value as 0.48, which is in between minus 1 to 1. Clear, guys? Understood?
Yes, ma'am. Yes, ma'am.
Okay.
Yes,
So
ma'am.
suppose there is a scenario like we have got the value of z that is around -3 or +3. Then what will happen after we include this tan h with this z value? For -3, we will be getting the value around, for -3, we'll be getting the value around 0.99. Okay, so after we have used the activation function tan h in this value, if the z value is -3, I got the output value as 0.99. So how it is, we got the value in this form, like we get it in this form that for -3, if my weighted sum is activation function, I put it and output I got as 0.99. That is close to -1, right? And for 3, I'll get the value as plus 0.99, right? So this is how my value actually defines. So since I am getting the value between -1 to 1, so I got this S-shaped curve, okay? And like why do we use this form? Because it helps to get in through with the product, that where we get any of the data that is negative, to put it in the format that we can just form it in a form that we can just handle the positive and the negative values all together, and it works better than the sigmoid. Okay, in case of sigmoid, the range, what is the sigmoid? See, it is also S shape, but its range is from 0 to 1. But in case of tan H, you see the range is from -1 to 1. So it easily handles the minus value altogether. Right? Understood, guys, what I told?
Yes, ma'am.
Clear?
Yes,
Okay.
ma'am.
Okay, guys, just allow me 2 minutes, please. I just need to have some water. Just a moment, please. Okay. This is actually tan H, how we'll be doing it down. So this is the form we have taken it down, the tan H one. Okay. Next we can take about the ReLU one. This is the another activation function. So ReLU is actually rectified linear unit. So it is one of the most popular one you can think it of in case of activation function. Okay. So what is the formula of ReLU? Let me just first, because it is an activation function, we need to check about the formula. So formula wise, so how is the formula? It is ReLU output I'll be getting. So it is actually max of 0 to Z. So it is max 0 comma Z. Z is the weighted sum. Okay. So what we'll be doing it? So how it actually works? So it gives any of the value, like between, suppose we got any of the value, it will take it, the weighted sum may be anything. So it will take the maximum between 0 to to 0 to Z, whatever be the value we are getting in Z. Suppose we are getting the Z value as -2. In that perspective, what it does, it gives the max of 0 comma -2, right? So in that case, we will be definitely getting the value 0, because we will be taking the maximum value between 0 and -2. If the Z value is suppose 0, then we will be taking the max 0 comma 0, that is 0 only, right? And if we have got the value Z equals to +3, just a moment, +3, then we'll be taking as max 0 comma 3, right? So we'll be getting 3 out here. So if the value of Z is positive, then ReLU will give the value, like whatever be our z value, we will take it that only. The ReLU will give that function, that weighted sum only. If the value of z is 0 or negative, we get the output as 0. Clear, guys? Understood what I told?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, great, great. So there is, apart from all of this, there is a disadvantage in ReLU, that is the dying ReLU problem. Okay, that's why we use another form that is called leaky ReLU. What is dying ReLU? Suppose if z keeps being negative, like for every of the situation, the values being negative for some of the neurons. Okay, so we will be getting the value, the z value will always be 0, right? So in that case, it will stop learning, right? If for certain of the certain neurons, for we are getting this z value as minus only, right? Then what we'll be getting, since we are taking the maximum of 0 or the z, so for the all those process, we will be getting the output as z only, right? So in that form, it will stop learning, right? So that is the reason, that is actually dying ReLU problem. So that is why we have got the value for that is called the leaky ReLU, because the negative information that actually gets blocked in this case. Okay, until and unless we are getting any of the positive value of z, the value, like the data is not learning, like the model is actually not learning. Okay, that's why we taken into count for leaky ReLU. So it is what it is. It is the improved version of ReLU that actually tries to solve this dying ReLU problem. Okay, because tanh, in case of that, it doesn't work good with the negative value. That's why we want to take it as in the form called leaky ReLU. Guys, understood till now what I told? Clear it is?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So we'll take into account out leaky ReLU. So what is the output? So if z is greater than 0, okay, so then it's fine. If z is if z is less than 0, then what it does, it it is like alpha into z it does. Okay, so what alpha is, or I have write it as a only, but it is alpha. So it is as a small number that is being added it up to it. So suppose 0, sorry, 0.01 maybe. Okay, so what actually it does? So if the value of z is greater than 0, if it is positive, then it's fine. If the value of z is less than 0, then it tries and add it with any of the value, that is with a, suppose it is adding it up. So what it does, so suppose it is trying and adding it out. Suppose we are getting the value of z as -2 in the weighted sum formation. So in leaky ReLU, what we will be doing? We will be doing suppose 0.02, that is minus, we'll be getting it at around 0.02. Okay, irrespective of previously what we were getting, we are getting totally 0. But now what we are getting minus 0.02. If it is suppose 0, if the z value is 0, then what we are getting in leaky ReLU output, we are getting the value as 0. But and when the value is around 3, suppose in the output we are getting as 3 only. Okay. But in case of -2, what we are doing, previously we are getting 0, but now we are getting minus 0.2. Okay. Clear? Understood?
Yes, ma'am.
Okay.
Yes, ma'am.
So for ReLU, we got the output range that is 0 to infinity, But in case of leaky ReLU, we'll get the output range as minus infinity to infinity. Clear? Understood?
Yes, ma'am.
Okay. So this is the ReLU activation function. So see here we are getting the 0. So that's why it is taking the line like this and it is going up. Okay. But in case of leaky ReLU, because it also adds on the negative side, will work accordingly. Will get the value accordingly. Like the graph will be like this. We'll get the line of the graph in the negative section also, like the negative quadrant also. Okay. Now we'll work with this softmax activation function. So softmax function, what is this? It is the activation function that is used in the outer layer of the neural network when we are actually trying and solving any of the multi-class classification problems. So this is actually based on the multi-class classification problem. So it is actually based on multi-class classification problem. Okay. So what it actually does, so basically it adds the activation, like generally we try and use it in the after we are done with the Z value, we try and put the activation function. But here the activation function is used in the output layer of the neural network and it tries to solve some of the multi-class classification problem. Okay. So it converts the raw score, suppose any of the raw score or logics, if you can say it like that, into a probability that actually tries and sum it up to 1. Okay, so it converts the raw score actually into the probabilities. Okay, got it? Understood, guys, what I told?
Yes, ma'am.
Yes,
Yes,
yes.
ma'am.
Okay, so let us just take an example. Suppose we have the class as classes, different classes we are having. That is, suppose cat, suppose dog we are having, and suppose horse we are having. Okay. Next, then the raw score, that is the Z value for each of them. Suppose 2.0, maybe 1.0, we can say, or maybe 0.1. Okay, so these are the Z values that we are getting. Okay, so now what it is, we need to use the formula that is, it is a huge one, that is actually e to the power Z, and it writes as I, sorry, sorry, just a moment. And it is the value, and now we are doing like the e to the power for the ith position, because we are getting see, just a moment, let me just go up. See here what we are doing, we are getting the input, here it is the output, before the output we are doing the linear sum and activation function, right? And here also when we are getting this, here we are taking into account getting the input, doing the activation function, doing the weighted sum, activation function is doing. This output is going for this layer, whatever the output we are getting, going to this hidden layer. Then again, the weighted sum is happening, for activation function is using. Now we are going ahead with the output is going to this. Now here, after this, the weighted sum is happening, then activation function is happening, then we are just going ahead with the output, right? This is the final one that we are taking into count, right? So, but here in case of softmax, what actually is happening? In case of softmax, we are taking into count that we are taking the value in a form that we are taking all of the values here, like all of the values, weighted sum is going here, then it is going here, then the weighted sum is going here, and only here we are putting the activation function. Okay. So this is how we are actually taking it down for softmax. Yes. So here what we actually are doing, so we are taking the weighted sum, the e to the power, the weighted sum value for the ith position. Uh, Now we will be doing e to the power z value we will be taking for one first position, plus we'll be doing the same for the second position actually. So till what point it is needed, we'll be doing it like that. Okay. For the second position, if we want to take it, it will be going like this, and we'll go it like this. Sorry, guys. Sorry. And for till nth position, it will go. Okay. Clear? Clear, guys?
Yes,
Yes,
ma'am.
ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
So E is Euler's constant, that is 2.719, so 718 actually. That is 2.718. So this is the form of softmax. So this is the form we are taking into count with the softmax. Okay. So after we are doing, what are the stepwise? We got the raw scores, that is the logits we are getting. We are creating like the exponentiate each of the score. We are doing the exponentiated form, like the e to the power, this form we are actually doing. Then we are doing the sum of all of it. And for each of the class, because we have taken like cat, dog, horse, each of that, we will be taking it down. And based on that, what we will be getting in the output or the final output, we will actually get the probabilities. Okay, so maybe for the cat class, what is the probability of getting cat class? Suppose 65% is the probability after doing all of this in the output, I am saying. Okay, in the output, you'll be getting the probability that is around 65%, maybe cat class. In the dog class, it is 24.2% maybe. I'm just giving an example. There is no point that I can calculate it now because it will take a time consuming. That's why I didn't do it. But I'm just giving it some of the example. And for horse class, maybe it is around 9% or 10%, maybe 10%. Okay. So this is the form we can take the probabilities into count in the output section. Okay. So this is how we can use the softmax. And next we have the soft plus. So in the soft plus, what we do, the for the soft plus, we have the, let me write it up here. So for actually what we do in the soft class, the formula is ln, that is 1 plus e to the power z. Okay, this is the formula of soft plus, where z actually is the weighted sum. E, all know, I have already given you the details. It is the Euler's constant, and ln is the natural logarithm, right? So this is how we are actually taking. So how it actually works. So similarly, we will be getting the input, the weight. We will be calculating the weighted sum. Now we'll add the soft plus formula. So this formula, what is be there, we will be putting it. After suppose putting it, we'll just curve it. Like if like suppose for minus 3, maybe the this value will come up to be around like the approximately, suppose we'll get it around 0.05. Okay. Next, suppose for 0, we will be getting it around after putting it to logarithm, we'll be getting 0.6 times, right? And if the value is like that, if the value of z we are getting as plus 3, then we will be getting the value as 3.04, right? So what actually it signifies? So the curve that we are getting, that is smooth and gradual. So for any of the values, like the value for every, like the negative value what we are getting for z, it is approaching to 0. See, this value is very close to 0. And if the value is about, suppose this value, for this value the z is suppose plus 3 or positive value we are getting, so you can see the output is pretty much closer to the z value that we are taking into count, right? So this is actually soft max. Understood, guys, what I told?
Yes, ma'am.
So for
Yes,
this,
ma'am.
okay, great. So for this, when we are getting the negative value, so the value output is very small and we'll get a very small slope, like a small gentle slope. For 0, we'll get a medium slope, but plus we'll get a strong output or like a climb up is like see, this is a this is a straight output, right? So see, for negative, we got this line, straight line, like it has no peaks, very gentle slope. You can see like no gentle slope in this section only. Then for 0, it is a gentle peak. You can see in 0 that it has came up a bit. And in case of plus, see these values are plus, so it has got a strong or a sharp peak. Clear? Understood, guys?
Yes, ma'am.
Yes, ma'am.
Everything
Understood.
understood?
But
Everyone
ma'am, I
clear?
have one doubt.
Yeah.
Why we are writing this in numeric form? Because we are means we have been created the graph once. Then why the need we need to do these calculations?
I didn't get you.
Means for what purpose we are doing these calculations? We have graph, so in that graph we can see the visualization. So why do we are doing this calculation?
See, we don't know about the data that we will be having. So it is a normal graph. So here, suppose the value or the inputs that we have got around 10, 7.5, 5, 2.5. There might be situation, right, where I have got the input value, that is the input value. This is out of this range. Suppose maybe minus 12, or here maybe or plus 20 is my input. Then how my curve is performing, like how my value or data is performing, that I need to check in through, right? That's why we are actually calculating. And even we have got this graph, but while our model will learn, it will not stick to the graph, right? It will take the output and it will try and do the mathematical operation, and then will do the activation function, put it into the activation function, right? That is the reason we are needing to do the calculation.
Okay, ma'am,
Understood?
got it. Yes, ma'am. Thank you.
So this was your question, or I understood it wrongly? Actually, this was your question.
Yes, ma'am. I didn't understand that we have the graph. Then why we are doing the calculations? That was my point. So I was
Yeah.
confused there.
So see, there is in the graph only there is certain range up to this how this graph has built, right? Suppose any person have taken all these inputs and understand the trend how it has came up. Based on that, for those specific range, he has understood and given the range it like that. But how, what
Okay, ma'am.
my z value will come up and how it will work based on my activation function, that is not sure of, right? So this maybe for any of the, like this trend will follow, but to what extent it will follow and up to what much, it is not sure. For this we need to do the calculation. And the whatever be my neural networks that are there, they actually will not count up or will go according to the graphs, right? They will do the mathematical operation, then will try and include this activation function. Right? Understood? Now it is
Yes,
clear.
ma'am. Means the graph will be depending on the data we are choosing or been given, right?
Actually, this data, what this actually tries and follows the same pattern. See, here I have given you the like the insight, right? If it is -3 or the values of z, I am getting around minus negative. It will try to come close to close to zero. The value I am getting, that is close to zero. But for any of the values, suppose -10, to what extent the value will come up, I don't know, right? So it will come close to zero. Maybe it will around 0.12. What exactly is my value, that that I can't get. But from graph, I am getting like it will come close to zero. And for plus, I have given you the insight that if the value is plus, then for the soft plus, the after the output that I'll be getting, that will be close to this, the positive value of this only, right? It might change.
Yes,
Here it
ma'am.
is 3.4, but it might be case that it come up to 3.6, 3.06, or 3.8. So that exact value I need to calculate, because I can't work on approximation, right? I need the exact value to take it down and go for the activation function and get the output. Because if I take approximation, then it will affect my model. It will affect the way my model is actually working, right? So that is the reason I need the exact value. That's why I need to calculate. Clear?
Okay, ma'am. Got it. Yes, ma'am. Yes.
Okay, great. So we'll just go ahead with then other parts. Let me just see what we are remaining with. Just a moment, guys. So we'll just scroll it up. We'll see what we are actually lacking up. Yes. So basically, we have this types of neural networks. So we have single layer perceptron, multi-layer perceptron, feed-forward network, convoluted neural network, recurrent neural network, and long short-term memory. Right. So we'll try and look into them into some of the in a bit details, and then we'll just go ahead with the coding part so that it becomes easier to understand, right? In just a moment. Okay, so we'll first see about the perceptron. So what perceptron is? Perceptron is actually the simplest type of artificial neural network. First, actually, the perceptron has invented. Eventually, we have taken it down to multi-layer perceptron, feed-forward network, then a convoluted neural network, recurrent neural network, and LSTM, that is long short-term memory. These are the advanced version of the neural network. Okay. So what actually this perceptron takes, it what let me just write it down so it becomes easier also to understand. So in case of single layer perceptron, what like in case of actually perceptron, basically, if we can think of what it does, it first takes some of the output because sorry, it takes some of the input because inputs are the basics. So they need to be taken into consideration. Then we just process them with weight and bias. Then application function, sorry, activation function we take into account. Then we get the final output. So in case of single layer, like the perceptron, what happens? The output that we are getting, that is actually 0 or 1. That is a binary we are getting, or we are getting yes or no. Yes or no. This is actually what we are getting in case of the single layer perceptron. So all you know, the input you know, the weights you know, the bias you know, the activation function you know, right? So everything when you are taking into count, so you are getting the value like this in case of single layer perceptron. Okay. So after you have done the weighted sum, you get the input, you know the input, you get the weight, you get the bias, right? So definitely you can calculate what you can do. You can calculate Z, the weighted sum you can calculate. Now after Z, you know, you can do the, after weighted sum, you know, you can apply the activation function. So activation function, when it is putting into activation function, what it does, if suppose we can represent it as like that, or we can do it at f of x, like this we represent. Suppose if it will give the value as 1 if the z value that we are getting that is greater or equal to 0, or it will return 0 if the value of z is less than 0. So this is actually the form of single layer perceptron. Okay. So we have got the input, the weight, the bias. We calculated the weighted sum. Now we have the activation function. So what my activation function does, if the value y, what is y? Y is the output. If the value of z is greater than 0, greater or equal to 0, my activation function will return me the output as 1, and if the value of z is less than 0, the activation function will return the value as 0. Okay. So this is actually it is. So suppose if I have the question as if the how is the weather? Is the weather cloudy? The answer will be either 0 or 1. So this is actually a classification type problem. Okay. That is tried to solve. Understood, guys, what I told? Is it clear? What is single layer perceptron?
Yeah, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
Okay. Everyone, any other question? Any question you're having, you can tell. Anyone, any question?
No, ma'am.
Okay, great. So, what is multi-layer perceptron?
Which will be having one or more outputs.
Okay, but output would be one, but multi-layer perceptron, what it would be? It is the advanced version. Okay, it is the advanced version of, just a minute, let me just write it down and we'll see it. So multi-layer perceptron, what actually it is? So here in this case, single layer perceptron, there is no concept of the hidden layer. So let me just go up. Actually, this is the form of the single layer perceptron, because there is only one single layer and I have the input values, the weight I am having, the bias I am having. I am just doing the weighted sum, doing the activation function, like putting it into the activation function, getting the output. This is the form of a single layer perceptron. Okay. Now, when we are now we are talking of a multi-layer perceptron. So from here, the concept of hidden layer comes. Okay. So from here, the purpose of hidden layer comes. Okay. So the layer, there is three layer. That is the input layer, the hidden layer, and the output layer. Okay. So suppose we are taking into account, suppose in the input layer, we feed the value with the input layer. Inputs are actually fed in the input layers. Okay. So after we have done the input, in the input layer, it will go ahead in the input layer value. It will have the weight and it will have, just let me just show you the value, then it will just work better, I guess. See, so this is the single layer perceptron. This is the multi-layer perceptron. So this, it has the hidden layer. So suppose in the input layer, we have given the inputs. Okay. Now what it will do in each of these lines, Now let me just draw. So in each of these lines that you can see that it has came up, so it will have the weights for each of the lines. So here for 3, we will be getting 9 weights, right? So we'll be getting 9 weights plus bias we will be having. So for this layer, it will calculate the Z value, okay? And then we'll put it to activation function. Okay, clear what I told?
Yes, ma'am.
Yes, ma'am.
Okay,
Yes,
so
ma'am.
this
Yes,
have
ma'am.
the weight, and here are actually the activation function lies in the hidden part. So this part, this Z actually we are doing. So this weights we are having, the bias we'll be having in this input layer. Then what we'll be doing, we will be calculating the value of Z. In the hidden layer, what happens in the hidden layer, we are having the activation function. So in the hidden layer, either we are going for ReLU or sigmoid or tanh, whatever be it will be doing. And then in the output layer, it will pass the value to the output layer. And for suppose based on the activation function, if it is sigmoid, the output will be binary, yes or no, right? If the value in the hidden layer, if the activation function is sigmoid, we are getting the output as yes or no. If it is softmax, then we are getting the different classes, maybe cat, dog, or what we have taken, maybe horse, right? So any of them will be there. If it is a linear fun, so we'll get regression, right? So we'll regression, that is the prediction we will be getting. So this is how actually it is working in case of multi-layer perceptron. Clear? Understood?
Yes, ma'am.
Yes, ma'am.
Okay. So we'll see about CNN. So we have the convoluted neural network. So convoluted networks actually works good for the images. So we generally try and call the CNN as a special type of neural network. Okay, where it does we mainly uses with the images, videos, or any other type of data that we can take into consideration from that. Okay, so what actually we does, we go ahead with build the building blocks. Like we try and make the building blocks. There are different layers. The first layer, so convolutional layer, or we call it the first layer. So what it does, it detects the simple things, maybe the lines, ages. This is the one where we calculate the lines, maybe the ages, whatever there in the picture that it tries to understand. Middle layer, or what it do, it detects the shape, maybe the eyes it takes into count, maybe the nose, what is the structure, basically it tries and understand about it. And this is the deeper layer or the denser layer. What it does, it detects the full object or the image, what is there inside the image, that it takes into count in the dense layer. Okay, so and we are getting a output. And here only we are getting the activation function that is taking into count about the output. Okay, so we are having this pulling layer. So what is pulling layer? It reduces, what it actually does, it reduces the size while it keeps the major information intact. And it tries to take, because as you know, when the size decreases and the pixel accounts decreases, we get a better view, and it's also better to store the values also, right? So this actually works. CNN actually basically works in case of the data that there we are actually having any kind of values that are basically image wise. So in the input layer, we take the image, in the convolution layer, what it does, it detects the simple features like the edges, corners, and thus then what we try and apply the activation function. Here we try and apply the activation function. What it does, it removes the negatives after we have applied. Suppose ReLU activation function we have applied. So in case of ReLU, what we get 0 or 1, like in the range 0 to 1 we will be getting. So whatever be the negative values, that is minus values, whatever we will be getting, that will get removed, right? Understood that this much? Understood? Guys, understood? Are you understanding?
Yes, ma'am.
Okay. So
Yes,
in the
ma'am.
pulling layer, what we are doing? We are doing the shrinking of the image, like squeezing of the image we are doing, but keeping the main info intact. What is the main or the vital information that we are getting? We are trying to keep that, but remove whatever the excess that is there, or we are trying to shrink it down. Okay. The image is trying and shrinking it down. So if we are having more of the convolution or pulling layer, so based on that, different work is getting done. Suppose we are detecting the other complex pattern that we will be taking into account. Like here, other if suppose after this also other pulling layers are there, then other details that are there that we are trying to get. Okay. And suppose after all of this has been done in the dense layer also, it tries and account for the full object, whatever be the full object that it tracks. And based on that, what are the features that we have also got? It tries and connect it with all of the portions. Okay. So we get the fully connected layers that combines the features together. Okay. Then in the output layer, suppose we get any activation function, maybe the softmax, we are getting it out here. So what it will do, it will predict the class. So if it is a dog class, it is a cat class, it is a horse class, what class is this? It will try and predict. Understood, guys?
Yeah, ma'am.
Yes, ma'am. Yes, ma'am.
Clear, everyone? Any doubt?
No,
No,
ma'am.
ma'am.
Anyone having any doubt? Okay, fine. So we'll just go ahead about the recurrent neural network. So it is what it is. It is a special type of neural network again, because this one was a type that is the special one. Recurrent one is also a special one. So what it does, it uses the sequential data. So the data that has a specific order, it try and use that. Okay, it is, we can think it of or treat it as a memory. Okay, it takes step by step, one step, like as we take like one word one at a time we take, then we try and create a sentence, and this we take it down. So in the similar format, it is we can call it as a memory, and it contains the current input value. Also, it contains the past information that is there inside the memory, or any of the state that is there. It will just try and take into account. So it is actually working as our normal brain. So it's not like the current information that we are feeding to my brain, it is there. Along with that, the data that is there like 5 years back, that data is also there, right? So recurrent neural network actually tries and work with that. So input, suppose I am putting the values in a form that in this value I am putting three values in the sentence or a word case. Maybe I can put it like I love my country, like that I can put it down, right? So next, what it will do in the hidden layer or the memory part, it will do, it will state the stores. It will state the store and will try and connect how much it remembers. Okay. So suppose in the memory part, what it will do, I love my country. I have put it like that. So for each of the section, it will try in the first, it will try and remember what it is been fitted. So it is I. Then in the second word, I love. Then I love my. Then I love my country. So this is the form it will take into account. And in the output, here it will work like this. And in the output, it will give what it is. What is I is a pronoun, so it will come like that. So I love what it is. It is a verb. So it in this way it will get segregated. Understood how it is actually working?
Yes, ma'am.
Yes, ma'am.
Everyone till now up to what we have read, what we have studied, any question, any doubt, anything?
No, ma'am.
No, ma'am.
Okay, okay, fine. So we'll just go to the form and we'll see the codes. Yeah, this is the code that we have. So here we have used the single layer perceptron using the iris classification data, because the single layer perceptron, we know it gives the output as 0 or 1, yes or no. So in this format, we can take it like that. Okay. So first we have imported all of the necessary libraries that is needed. So we did it like that. Then what we did, we have just taken into account after we have taken the imported the libraries, we need to load the data. That's why we have taken into account, we have loaded the iris data that we want to take into consideration. Now we need to pre-process the data. So whatever be the categorical data that we are having, we have changed, like we did the one hot encoding, we changed it accordingly. Now we have just splitted the data into test and train format, because we need some of the data for testing and some for training part. Next, we have taken into consideration the scaling features, because we need to scale the feature. We need to take into consideration if it work well. Next, we have just gone ahead. After we have scaled it, we have built the single layer perceptron model. So we have the input layer that contains the 4 neurons, because the iris data is of 4 features. So what, based on the features, the neurons will be counted. Okay, if my data set have five features, then 5 neurons will be there in my data. Okay, then we have got the hidden layer. So that will have what I have used up here. We have taken the single layer perceptron input 4 activation function. We have used the softmax, and then we have like in case of hidden, we can try and use any of the form, like any of the other form in the outer like the outer layer. There would be three values that we will be taking into account, like the 3 neurons, because we have to distinguish it into 3 different classes, right? Because in we know about this iris data, so at end we have 3 different classes. So that's why in the output layer we have got this 3 values, 3 output values, because of 3 classes, and the activation function that we have used, that is softmax. Okay. Now what we did, we have just trained the model and just compiled the model. Sorry, we have just compiled the model accordingly, trained it, and now have gone for the evaluation so that it can try and make the prediction. What is the predicted value it has got ahead? What is the actual value? See, so it has given me all of the process, like how it has for every iteration, it has worked, and it has calculated what is my accuracy level, what is the loss, what is the value that we are getting it, and how much the loss is reducing, because my intention is to come get the value accurate, like closer to the accurate value, my predicted value closer to the accurate value. So each point I want to calculate the loss, whatever, because the lower the loss, more closer the values are. So after this is my predicted value, and this is my actual value. Because I got the loss value closer, but 0.5, it has came up. So I have got one value that is mispredicted, but all other four values that has got clearly predicted. Understood, guys? Clear? Everything is clear?
Yes, ma'am.
Yes, ma'am.
Sure?
Yes, ma'am.
Any?
Yes.
Yes,
Okay,
ma'am.
okay, got it. So similarly, we'll just take on for this multi-layer one. So just a moment. So it is a multi-layer perceptron. So here we have taken, we have to take the data. So we have just gone ahead, imported the libraries accordingly. So we need to calculate, like we need to put it the, like we need to put the values accordingly in a form that we can check the fix, like we need to fix the seed actually. So that's why we have taken it down like that. Now we have to load the data set. We have used the iris data set here. So see here, we have taken the data. So now we need to split the data, split the train and test data we have done. So 80% we have kept it for the training, 20 we have kept it for testing. Next, what we did, we have did the one hot encoding we actually did here. So because we need it for going ahead with, then we did the normalization because in iris data we have got the categorical data. We need to change it to numerical data. That's why we have taken into count like this. Next, we have normalized the data. We have used standard scalar to create a scalar object. So after that, we have used the X train, we have used the X test, we have taken into consideration. Now we have built the multi-layer perceptron. Okay, so what we did first, we have used the sequential where you have, because we need to start building our neural network. So we have started it like that. Now, next, after that, we have used model add. What it adds? Dense, it adds 16 input shape 4 activation ReLU you have used. So it is the first hidden layer that we have taken into count because as you know here we are using multi-layer perceptron. So multi-layer perceptron does has the middle hidden layer, right? So that's why we need to include the hidden layers and what activation function we need to put in each of the hidden layer that we need to take into count. That's why we are using this. After model sequence, we have started with the model. Next, model dot adds, we add the hidden layers basically. So basically in the hidden layer, first we have used 16, that is the 16 neurons in the first hidden layer we are using. We are using ReLU activation function you are using because and we are including input shape 4, right? So you can see I have put it input shape that is 4 because we have like 4 classes for each flowers we are taking into 4, right? 4 features actually basically. So that's why we have taken into count like that. So for each of the flowers, we have got 4 specifications or 4 features. That's why we have taken this 4. Next, we have added the next hidden layer that contains 12 layers of neurons, and the activation function I have used ReLU. Next hidden layer that we have taken into consideration. So here we have used 8 neurons, and the activation function I have used ReLU. And in the model, what we have used, we have taken into consideration. This is the output one that we have considered, and we have considered the 3 neurons because 3 classes are there. That's why 3 neurons and activation function I have used softmax. Okay. Next, I have gone ahead to compile the model. So it has the optimizer that updates the weight. This optimizer, the work of optimizer is to update the weight. Loss, that is categorical. This one categorical cross entropy, that what it actually does, it compares the predicted versus the true class constantly. It predict the what is the predicted class with the true class. It tries and predict like that. And matrix, I have used accuracy, that measures the accuracy for each session. Okay. Next, I printed the model summary. Now, next we have gone ahead with the training of the model, evaluation purpose, and we have just made the prediction. Okay, so what it does in the prediction purpose, here bread props actually, it what it does, the model predicts the probability. What is the probability of each class it predicts? Next, what it does, it converts the one hot test back to the integer. Okay, this class back to the integer format so that it tries and use. Now we have just gone it and use it. This true class actually do it in this format. Okay. Now we have just trained the model accordingly and got the predicted class along with the true class. So see here, my loss is very less, 0.08. In the previous code that we have taken into account, what was the code, what was the loss? That is 0.5. That is very huge. That's why, that is very huge in the sense, compared to this, it was huge, right? So that's why we have got one class misclassified or mispredicted, right? But here we have got the loss value very less and we have got this. That is why we try and use this multi-layer perceptron and try to use more hidden layers with different activation functions. Clear, guys? Understood?
Yes, ma'am.
Clear? Everything clear?
Yes, ma'am.
Sure? Any question? So we'll just go ahead with the next one. So here we have taken with another one with fully connected ANN. So how we have taken into consideration there, we'll check it once. So we have just gone ahead, imported the libraries accordingly. We have then loaded the data. Whatever me by data, I will take into consideration. I have loaded it down. Then we can just quickly just want it and work it because I need to work with the pre-processing part. So I need to check it with the training part and the testing part. What is the shape of it? I want to, because after I have just created the train and test, I need to check the shape, like how actually it is, how actually it is looking. So that's why I just checked it out. Now I have done the pre-processing part because I need to work with the pixel. Because it is image based, I need to work with the pixel. That's why we have gone ahead. Okay. Now we have taken the values, converted to integers, build the sequential neural network. How we have taken, like the similar, we have added here one, two, three, four forms, because here we are forming the CNN basically, like the CNN forms. So we have taken the values and taken in the form like how we want to take into down. Now we have taken, compiled the model, print the form, taken into the evaluation, tried and plotted the form in a form that we get the output. So I just wanted to print it. So it has printed the value for the dense, how it is working. Now it has just trained it and I got the value like true 7, predicted 7, true also 7. So I got the value 7, true predicted. See, this is how actually we have taken into consideration. Understood, guys? Everything clear?
Yes, ma'am.
Yes, ma'am.
Yeah,
Okay,
ma'am.
fine. So here,
Yes,
there,
ma'am.
what we actually did, here we actually taken into account with the fully connected ANN that we have taken into account. Here we'll be using the CNN basically. Say CNN is the convoluted neural network. The similar way we have taken imported the libraries, loaded the data set. Now we just pre-process whatever be our data, we pre-process. Now we converted the one hot encoding that we did. Now we need to build the CNN model. So what exactly we are doing in case of like there you understood, like we are trying and adding the hidden layers. Here also we are trying and adding different hidden layers. So I have given you the names. So here we have just started it off, like we started you building the CNN. In here what we have used the first convolution layer. Like after this part, this is con 2D, you can see the here we have used the first convoluted layer. We have used 32 filters here, and we have taken the kernel size as 3 cross 3, like 3 cross 3 pixel it will take or consider at the same time. Here activation function we have taken ReLU, and the shape that we need into consideration, it is 28 cross 28 is the image pixel shape, and one is the channel with one channel, that is the grayscale. Okay, understood? Next, we have gone ahead with the pulling layer. We have taken it down with 2 cross 2 pixel. Next, another way with this one, we have taken another pulling one. Then we have taken the flattened one. Then dense out. Then drop. We have taken it out. And final, the output layer we have taken into form. Then, as usual, compiling the model, print the model summary, whatever the summary that is there. Now we need to train the model, evaluate the model. We need to take for the prediction. See, for the first one, we have taken the output because I need to print it down. So 26, 26, 32. For the pulling, 13, 13, 32. Then this form it has taken out. Now it has just trained itself, and we have got the predicted class along with the true class. So it has predicted very well, because here we have got the loss value accuracy. It is giving as the test accuracy. Basically, it is giving as 0.99, that is 99% accuracy this model is giving. And based on that, the value basically we are getting it is 99.01, that is the one, and the loss it is very less, that is 0.03. So see here how we are using the model and what activation function we are putting in, because this activation function and the hidden layers we are putting on our wish, on our will. So it needs to turn into a perfect form that we can try and use it in a form that we can try and get the ultimate form. So suppose in any of the form you have used tan h in any of the function, and after that, after training, you are getting the accuracy as 80%. Then try and use more hidden layers. Try and use other activation functions so that it can try, like your data can learn from that, and based on that, try and use that, used to see that accuracy. And in that case, don't just delete it. Don't just delete the form. Take, like, use that model, the TANH model that you have used with TANH activation function that you have used. Keep it so that you can see the change. What change it has made in case of the accuracy purpose. You can see it. You can understand it. So that is very necessary for your learning. Like where to use what activation function, and how many hidden layers you can try and use, how many hidden patterns you can use. That is very much needed for you to understand. So similarly, here is another recurrent neural network for the sentiment analysis. So here we have just taken it down with importing the libraries basically. Now loaded the data set. Then we have got the pre-processing, whatever be the pre-processing. Max length we have taken as 200 because we decided whatever be the review that we will be taking, that will be around 200 words, not more than that. Okay, so that is the case we have taken into count. Next, we have built the RNN model. So we have started with the model. Next, we have just include the embedded layer here. So what we are doing here in case of embedded layer, the input index we are taking to input index we are taking into account. Next, we are taking into account that 32. 32 is the dimensional vectors that we are taking into account, and we are taking the length. Next, what we are doing, we are using the form that we are using the activation function as tanh, and this is the outer layer. There we are using the activation function as sigmoid. Now we have gone ahead, compiled the model, printed the summary, we have trained our model, evaluated the score. So see, we have got for embedded the shape we haven't print. We have got U, the 0 that is unbuilt. Then it is like this. And after the values we have got into, after we have trained it for around 3 epochs, we got the test accuracy as 82%. That can be considered good. So we can take into account with this value and we can work. And if needed, we can try and use the other forms also, try and see and work accordingly in this part in building the RNN form. In what form it can work better, we can see. But 0.82, that is 82% accuracy, that is better than 80% of accuracy I am getting. That is not that bad. So here you can see the accuracy as 0.82. See, in the first session, the accuracy in the first epoch, it has got 0.61. Next, it has increased to 0.80. Then it has increased to 0.85. So here from first epoch to second epoch, it has worked magnificently. Like it has learned hugely. So it has backtracked itself and learned accordingly and came up like this. So, guys, clear? Understood?
Yes, ma'am.
Yes, ma'am.
So, everything clear?
Yes, ma'am. Yes, ma'am.
Okay,
Yeah,
great.
ma'am.
So, accordingly, this is what we had to complete in this week actually. So, accordingly, projects will be given to you. You can work with your project in the weekend, and based on that, you can try and perform your model. Like if you are working with any of this, like suppose you are working with any multi-layer perceptron. Suppose your model, you are trying to make your model understand and work with the multi-layer perceptron part. So in that perspective, suppose you first, in the first case, you have tried and used two hidden layers. And suppose in the first one, you have used tanh, and in the second one, you have used suppose ReLU activation function, and in the final, like the output layer, you have used the sigmoid activation function. Okay, then you have seen that your output is coming up around suppose 70-75%. Okay, so then what you'll be do, first try to change the activation function. See what effect you are getting based on the activation function. Okay, because in the output layer, suppose it is a classification problem, then you can't change the activation function in the output layer, right? Because you need to get either 0 or 1, because your problem is classification based problem, right? But in the hidden layers, try and change the activation function so that you get to see what exactly is the form and how your how your uh, data that you are taking, that is working with that activation function. Fine. So after you have changed, suppose your activation function, now you are getting around suppose 80% accuracy. Okay. So then if you are not satisfied, you want to make it better, try to increase the number of neurons in the first cell that you are getting after the input layer. Okay. See if there is, if you are getting any of the better result. If it is, then it is fine. Okay. Don't worry. If you are not getting any result, try and include the hidden layer with other activation function. It is not for like it is not like that you can't use the same. Suppose in one of the activation function you have used relu, again you can definitely use relu, not an issue. You can definitely try and use relu, but see in what format your model is learning better. Your data is giving, based on your data, your model is giving the best output result. Okay, so this is the process you have to check and work with your neural networks. Clear, guys, everyone?
Yes, ma'am.
Yes, ma'am.
Yes,
So,
ma'am.
Yes,
guys,
ma'am.
Yes, ma'am.
and any
Yes,
query,
ma'am.
any issues?
No, ma'am.
No, ma'am. Got it.
Nothing?
No,
No,
ma'am.
ma'am.
Okay, fine. So I'll just suggest for any of the like suppose in any of the case you are working with huge data and you are working with CNN. Okay, then in that case you might feel like have you might have faced like it takes time. It does takes time. Like if you are working with really huge data, uh, the data that you have fed it in, the data is really huge, then it might take around 40 minutes of time also. But don't worry, don't close the session. Just keep it for 40 minutes. You will get the result. Like since it is timing, there are like you there are if it is like taking a lot of time, you are just tendency like you just stop it. You just don't try like wait for that long, but try and use for that long if the data is really huge. Fine. But in that case, I don't think you'll be getting that huge of data. But in certain case where we are working, but we are getting the data that is really huge. So we need to take into account with that. But apart from that, the parts are good. You can work accordingly in that form. Okay, and any of the classification based problem or maybe any of the regression based problem you are getting, try and use first the like first try and use the single layer perceptron, then try and use the multi-layer perceptron so that you can see the difference how it is actually working. It's like it is better for you to understand. Like I have also today also given you the example, like in case in any of the classification based problem, when we have used the single layer perceptron, we have got one class that has been mispredicted, right? One mispredicted data we have got. But for the similar data set, when we are using the multi-layer perceptron, we have got the best output, best result, and accuracy also we have got really good. So try and use it in that format. Okay, guys.
Okay,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, ma'am.
Okay. So guys, hopefully you have submitted, all of you have submitted the last 4 year, like 4 week projects you have already submitted.
Yes,
Yes,
ma'am.
ma'am.
Yes,
So
Yes,
those
ma'am.
ma'am.
who, great. So those
Yes,
who
ma'am.
have not presented in the session, for them, I am just asking, have you just recorded the session, like recorded the, like whatever be the presentation of your project and accordingly submitted, because that is very much needed for the evaluation. Okay.
Yes, ma'am. Done.
Yes, ma'am.
Okay. Okay, great, great. So, so this week also you'll be getting the project by today by end, like sometime after that, or by tomorrow you will get the project. So work accordingly with the project and calculate the accuracy as I have shown, so that for each epoch you get the accuracy level, so that for each epoch you can check how your model is performing. Okay, and it is also good, like you can see when you are running the CNN, if you are printing the epoch or printing the summary, then in that format you get to see like for how many epoch is completed, how many epoch is left. In that form you can just check it down. Fine. So try and use it in this format. Okay, guys.
Okay, ma'am.
Yes, sir. Yes, ma'am.
Okay, fine.
Okay, ma'am.
So we'll just stop today here, and
Ma'am,
Monday is your,
ma'am,
yeah, yeah.
ma'am, my friend is interesting to join internship. So could you tell me when we new session start?
Sorry, I just missed out. Can you come again?
My friend joined too interesting to join the internship. So could you tell me when the new session will be start?
Okay, that I don't know. Can just mail the HR. Okay, so based on that, they will definitely ask, like definitely give you the insight so that you can just revert the information to your friend so that based on that he can join in.
Okay, ma'am.
Yeah,
Thank you, ma'am.
because I don't have any proper idea when next session will be, like next batch will come in or next session, like based on this. Okay, for the internship purpose.
Okay,
Okay,
ma'am.
so you
Okay,
can
ma'am.
just mail the HR. Okay,
Okay,
so
ma'am.
guys, I guess everything is clear. So we'll meet on Monday and we'll go ahead with the presentation. Okay,
Okay, ma'am.
okay,
Ma'am, I have a one doubt. Shall I ask?
yeah, yeah, yeah.
Ma'am, actually, that Google form link, there is only GitHub. So we are putting the GitHub. I submitted for project, but where I submit the recording is not taking there.
So there is a option of submitting the like the video presentation link, right? There is an option of submitting the video presentation link in the Google form only,
No, ma'am,
right,
I
guys?
was checking that I already submitted it, but there was only taking the GitHub link only project wise, all six project, 6 week. So I submitted up to the four, but there is no their side no asking the videos. Where I submit the videos.
No, no, video in the form of link you have to submit. Okay, guys who have already submitted, can you just tell me whether there is a option of video link submission like that? Anyone have seen? Like anyone have, other than him, anyone have submitted like that?
There is
Yes,
no
ma'am,
link
through
for uploading
the
the video, but we made a file in our drive and upload the Jupyter file
Yeah,
there and the
actually.
video there as well.
Yes, that is the drill only. I have already mentioned you like we have to do it in that format. You have to record like it is not like you have to upload the video in the Google form. It is not like that. It is not possible also, right? You have to whatever the video you are preparing, you have to go and save that video or upload that video in your drive, and there you have to give us the permission. Like when you put the option of share, you get two options to share to whom. So there you have to take the like checkbox that option that anyone having the link can get the access, can give the access of this video presentation like that. Okay. So like that you have to submit it. Then you have to just paste the Google Drive link actually in that point.
Okay, ma'am. Okay. Okay, ma'am. I will
Okay.
do that.
So you haven't submitted the any of the videos, presentation video.
No, ma'am, because I was not getting. Actually, I was busy, so I submitted before the after for fourth project. So we submitted all fourth. We prepared everything, videos, everything. Everything is ready my side, but we are unable to
Okay,
do. I was putting only their side asking the GitHub, so I put it only the
I
GitHub
got it.
all four
But
projects.
in the session, I have told multiple of time there is no query. There shouldn't be. If you're having the query, why haven't you asked me before? It's not like I don't answer any of your queries, right? This kind of queries I try and answer, right? And this question I have asked you, I guess, multiple of times. I have answer like given you the answer, irrespective of whoever has said or whoever have not asked. Also, myself, I have given you this like idea like how to go ahead and submit. I have told this thing I guess multiple of times. Where were you? Why you haven't listened?
Actually, I was not getting time, so sometimes I watch half video. Then after that half video, I was watching on after finishing my job because we are 2.5 hours is the back. I'm living in foreign, so that's why when you started the session
Okay,
on that time I was on duty. So that's why we
okay, okay.
didn't complete each and everything. That's why it was late. So last time I submitted all four project. I also recorded there.
Mhm.
So I will do it like that. So I missed some
Uh,
video live.
yeah,
So
I
I watched the
understand you'll
recording.
do it. I understand you'll do it. But the thing is, there is certain deadline, right? That you need to maintain. Like in your job, there is, if your client is asking you something, there is a deadline, right? For the submission of that project. Here also, we do have a deadline. So I guess recording also given to you so that from there also you can get it through. But no worries. But if everything is ready, you try and submit it by this week along with the new project. You do it and submit
Yes,
it.
ma'am. With the fifth project, I will add it all the things.
Okay, okay, great, fine. Okay. So, Ranvijay, if possible, try and if it is possible for you, this week you just present your project in the session itself. Fine. That will, so that we can also see, right? Because there we have to go ahead and if you will be uploading, then we have to see. So, if possible, you can just present your project this week in the session.
Okay, ma'am. Okay, ma'am.
Yeah. Okay, Ranvijay. Fine. Okay. Anyone having any queries, any doubt?
Ma'am, I have submitted 2 weeks project.
2 weeks project. So it's going fifth week. So you have to submit two more project that is pending, and this week you will be
Yes,
having
ma'am.
one more project.
Actually, I have joined late, so that I have submitted 2 projects. Then I will be submitting very soon.
Okay, fine. By try and submit it with this week, fine, because we'll be having time. So try
Sure,
and
ma'am.
submit
Sure.
it in this week. Okay,
Okay, ma'am.
fine. Okay, guys, then bye. We'll meet on Monday, and Monday is the presentation session. So, guys, be ready with your presentation. Okay?
Okay, ma'am.
Okay, ma'am.
Bye, ma'am.
Okay, bye, guys. Bye.
Bye,
Good
ma'am.
night. Bye
Good
bye.
night, bye, ma'am. Thank you, ma'am.
Bye bye. Thank you. Bye
Bye,
bye.
ma'am.
Bye.